Okay, so now in this video we'll see how a vocabulary tree is made and how it makes the whole process a bit faster. So this was how you divided your cluster in bag of words in 4 different clusters. In vocabulary tree, for example, making tree out of this phase will be like this. You had the data set and you divided it into 4 different clusters. Okay. This was at level number 1, and at level number 2 you divided it into 4 clusters. Now in vocabulary tree you divide these clusters into 4 more clusters. Okay. The value of clusters in which the number of clusters in which you want to divide depends upon you, obviously. If you want to divide it into 100 clusters, you can keep k is equal to 100, and then you will start it by dividing your data, like the features. Obviously these are the features that you divided into clusters. So you will make 100 clusters first, and in each cluster you will make 100 more clusters. So in this particular example I have kept k is equal to 4. So you divide your, these regions contain the same descriptors. Okay? So you divide it into 4, and then again at each this level you make 4 more clusters. So what you have done now is you have applied k means again, k mean clustering again in each cluster, dividing each cluster into 4 more clusters or k more clusters. So what you did is you divide k into another 4 clusters, and similarly you will keep going until k levels. Okay, again it is up to you to decide. For example, here in this case I have L is equals to 3. It means I have divided into 3 levels. Okay, and clustering value is 4. It means at each level I have divided it into 4 clusters. Okay, so this is how you construct your vocabulary tree. Now the point to notice is there is no feature descriptor at this level. Every descriptor will be on the leaves. Okay, on or you can say the roots. Maybe no, root is this, maybe this is called leaf. Regardless of this, you should know that your data is now here, because why? You divided, when the cluster was here, you divided it into 4 more clusters. It means you have moved your data from here to here. Now this is just a node. Okay, your all the data is now here. Okay, in the maximum level that you have set, that in this case is 3. Now the vocabulary tree is made, okay, and this is made out of your training data set. Obviously, let's say you have made it with, let's say, first 100 images. Now in online phase, in online phase, let's say you have another image and you want to add this image as well. Okay, you have another image, 101 first image, 101th image. Okay, and you want to place this image as well in this cluster, in this tree. So what you will do is you will simply extract the features from this. Let's say you extracted 10 features from this image, and now you will keep comparing each image, each descriptor, that in this case is, let's say, shift, with the nodes. Okay, obviously let's say this node will have some value, it will have some center. Obviously this node will also have some center. This node has the value of a center. What you will do is you will compare this descriptor with this one, and then you will decide where should you go. Should you go here, 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 or here? And how you will decide the path? Obviously by computing the dot product of this with the particular node. Okay, if this for example, if this is dot product is, or any scoring function, okay, it's up to you to decide. If this is more similar to your input, to the feature of your input image, then the feature will be moved to here, and then again it will be compared with centers of each clusters inside this cluster, and the least, and it will be placed inside the cluster where the distance between this one and the center of this cluster will be minimum. Okay, so you have placed your first cluster, let's say here, by moving from here to here, and then for example here you have placed your this descriptor here. Similarly, you will keep doing this for all the descriptors that you have found in the new image, and obviously it will be placed here. Acha, when you were training this model, or when you were adding another image to it, you were keeping a track of the paths that the descriptors in each image takes to settle in. Okay? For example, you found 3 descriptors, and let's say descriptor number 1 took this path. It moved from here to here, then here. Descriptor number 2 took this path, here to here, here. Descriptor number 3 took this path, here to here and here. Okay? You will keep noticing, you will keep saving this path somewhere. And how you will save it? You will use this vector. D is equals to M, I and W. Okay. Now each node has a weightage number assigned to it. Like, which should be more important node, this one or the starting one? Obviously this node should be assigned more weight, because this is deciding where your new descriptor lies. Okay? So it is in descending order. Weight of this will be higher than this, and obviously weight of this will be higher than this. Okay? So for example, if the 3 descriptors took this path from here to here, and then here, this one is the first, let's say this one, and this one is the second, similarly this one is the third, then what will happen is you will keep track of number of times this node was visited when you were adding the new image into this tree. So let's say this is visited 3 times. Obviously every descriptor started from this node, okay, when it was finding its way up. Similarly, this was again visited 3 times when you were adding 3 descriptors of this new image into this tree. And similarly, this was added 1 time, this was added, this was visited 1 time. So what you will do is you will multiply this score with the weight of this into 3, then weight of this into W1, which is 2, and again weight of this into W, let's say 1, 2, and then weight of this with, okay. So this is the vector corresponding to the new image that is added into the tree. Okay? You will keep saving this vector for every image that is inside the tree, because this will be used to compute the similarity between QE image and the images in the dataset. Now you have the new image. You will do the same thing. For example, this is your new image. First, what you will do is you will extract features. For example, you extracted 4 features. Then you will see which path will this descriptor take, okay? Or which is the most, and then you will compare the path taken by the descriptors in the new image with the path taken by the images in the data set, okay? And then by comparing the path of new image with the paths of already existing images, you will find the most similar image. Okay? The way you made this vector, you will make vector for your query image as well. Okay? Let's say for your query image took this path, this, and then this. And for example, it took this path, this, and this. This is the second path of second descriptor, and this is the third path. Let's say it was taken here, and fourth one was taken, let's say here. So again, you will make a similar kind with respective weightage. For example, node 1 will be visited obviously 3 times or 4 times. If the features were 4, so obviously it will start from here. So 4 and similarly, therefore now you know why this weightage is low. Okay, because this weight is more important because it is the decisive weight. Okay, it is deciding whether your new image is similar or not. So again, this is another vector. Now these two vectors will be compared. Again, there are different strategies to compare these two vectors, and one is this: you will simply normalize your vector by dividing your vector with its magnitude, both your query and the image in the data set, and then you will take the L2 norm. Okay, and on the basis of this score, you will decide whether your image is similar or not. So this has made the whole process very faster. Now you don't need to compare your new image with every other cluster. Why? Because now if descriptor takes, let's say, this path, obviously you have shortlisted your nodes to compare your image to. Okay? If your image has taken this path, it means now you don't need to calculate the score of remaining nodes. Now you only need to compare the score of the nodes that are here. So obviously the computational complexity, it also decreases in case of vocabulary tree. So this is how it is done. Hope so I was able to give you the idea of how the place recognition is done using vocabulary tree. See you in the next video.